Welcome to the South African Institute of Electrical Engineers, KZN webinar. Today, we will tackle a topic on unlocking South Africa's potential, how digitization drives industrialization and empowerment. I am Crystal Nagesha, the KZN chairperson, and today we are joined by three esteemed guest speakers, Tutukani Biela, Gosta Kellner, and Amin Hamdan. Today, our speakers will focus on Southern Africa, a discussion around showcasing how, as we embrace AI and smart grids, that can overcome legacy infrastructure issues, improve grid resilience, expand energy access, and promote sustainability for a secure and digitally empowered future. This afternoon, it gives me great pleasure to introduce our first speaker, Mr. Tutu Biela. Tutukani is the principal engineer at Sipu Latutu Engineering Services in Pretoria. As Southern Africa's representative and chair of SAIEE, Tutukani focuses on information systems, telecommunications, and cybersecurity. He drives innovation in information systems and digital transformation. Mr. Biela is also a member of the SAIEE D2 Strategic Advisory Group, where he focuses on the dissemination of information in Africa and contributes to the highest decision-making body for SAIEE D2. His work integrates AI to optimize power systems, cybersecurity, and distributed energy resource management for a sustainable future. It gives me great pleasure to welcome you, Mr. Biela, and we look forward to your presentation. I'd now like to hand over to you.
Thank you so much, Crystal. Or should I say it's good to be back. For me, KZN is home, and basically this is where my career actually started. It gives me a great pleasure to be presenting here after so many years, and thank you everyone for joining, and thank you, Crystal, for a great introduction. So, as Crystal alluded, my name is Tutukani Biela. My presentation is on unlocking South Africa's potential. Basically, it's going to focus more on digitization and sustainability, driving growth through technology and innovation. And I'm not alone today. So I've got my two colleagues, Gosta from Switzerland, and Amin from Canada. Later on, Crystal is going to properly introduce them. So as part of my presentation today, I'm going to start by covering who SAIEE D2 is, cover a bit of admin before I actually start with the technical presentation. So SAIEE D2, as Crystal has alluded, focuses on information systems, telecommunications, and cybersecurity. It got three advisory groups, one focusing on information systems. Within information systems, you've got your SCADA, your advanced metering infrastructure, your ERP, your artificial intelligence, your big data and machine learning. They form part of preferential subject 1 or advisory group 1, which is on information systems. Then the other advisory group is based on telecommunications. That one focuses on SDH, 5G, basically anything pertaining to telecommunication. Then advisory group number 3 focuses on cybersecurity. So there we're focusing more on developing frameworks, regulatory, and cybersecurity by design. As I proceed with my presentation, I'm gonna dwell deeper on each of these three. Then this is how our SAIEE D2 is composed. So it consists of 24 regular members, which includes South Africa, where I'm the representative for Southern Africa. Then there are also additional members and observer members. Then also there are active working groups, which are indicated here. Then also the strategic advisory group, which is basically the decision-making group. As I alluded earlier, there is advisory group 1, which is on information systems. Advisory group 2, which is led by Giovanna Dondosolo from Italy, focusing on cybersecurity. And advisory group number 3 is convened by our very own Zwelande Lembebe, a corporate specialist from ESCOM, or the states called MCCSA. Okay. Before I start with my presentation, I just want to remind you that the 12th Regional Conference will take place next month at CSIR, International Convention Center in Pretoria. For those who haven't registered, please register. The conference will run for 3 days. First day is going to focus on the tutorials, and in the tutorial, D2 is doing alongside C5, C6. So Kat is the chairperson of C6, and Aradna is the representative for Southern Africa. So we will be presenting a tutorial together. It happens that all 3 of us are from KZN, so I'm not sure how we managed to do a tutorial together. So please do attend if you get a chance. And I just hope I'm going to see more people from Exiwin. I think the numbers have started to dwindle, so we need more people from Exiwin to start writing papers again and also attend these sessions. And now let's start with the myth of this presentation. So my presentation, I will flow, then I will stop as soon as I'm done with telecoms, and then I will allow my colleague Costa, who's going to come in. Then under telecoms, I'm first going to cover the digitization. I'm also going to look at where we currently are and where we aspire to be. So yeah, let's get going. So basically, the challenge that we're currently facing is the just the energy transition and power upgrade 2.0. Now our consumers are becoming our prosumers, unlike before where power used to flow from generation through transmission down to distribution. That has changed over the years, and the introduction of the sensors on the systems and the use of artificial intelligence and machine learning basically has made the grid more complex. So with that said, we need to consider how we deal with all these changes. So we need to develop standards and policies to basically cover this going forward. And also, most importantly, we need to make sure that telecommunication doesn't become the bottleneck. So we've got all these nice applications, then we need to ensure that our network is able to deal with it. As I alluded, that telecommunication is an enabler for Power Grid 2.0, smart grid. So in my previous presentation in June, I compared our system to anatomy, where transmission and telecoms is the bloodline, the blood vessels, which basically allows information to flow between different points. So it allows for the bidirectional flow of information. Digitization is the heartbeat of the network, and then the applications like your AI that we use for predictive maintenance becomes the brains of the operations. So with that said, we need to ensure that we build a resilient telecoms or nodes to support all the applications and the changes that are happening on the grid. So this is where we aspire to be as a country and the changes that are happening globally, as I mentioned earlier. Previously, we had large inertia power plants, so everything used to flow from generation down to the customer. The grid was more predictable and stable. Now, with the introduction of embedded generation, consumers becoming prosumers, now you've got power electronics-based production coming up. Then you're not sure in terms of electric vehicles how it works as well, because a consumer can be back during lunch to charge their basically cars, which makes the grid more complex and basically unstable. So there are three, I'm going to cover these things in threes. So the first 3 points, which I will cover with Power Grid 2.0 or the changes that are currently happening, is security, green, and efficiency. So how the new power grids or the current and the grid of the future are built is that we are looking more to reduce carbon emissions. We're looking at energy saving and clean energy. In terms of efficiency, we are more focused on asset management, basically being customer centric and so forth. And also the security of the grid is also important going forward. Then another three, which I'm gonna cover here, is the real-time dynamic balance, the digital technology, and new energy challenges. So we're looking at real-time. I will focus more on situational awareness. I think Tegwin at some point was looking at developing an energy management system. The concepts of digital technology and the use of digital twins and the use of IoT to receive data from different points in the grid has actually increased. And basically, that is what the age of digitization is all about. It's about the use of information, building a strong network and the cyber security by design kind of a network. So that is where we are. Then the fifth industrial revolution will focus mainly on AI and the intelligence thereof. So with all these new services and applications are coming up and looking at the current state of the grid, let's look at the power operational technology. We've got different need compared to the enterprise. So there we consider what is called control, AIC, which is your control availability, integrity, and confidentiality for services like teleprotection, which are time sensitive. So you need to ensure that the packet gets to the other side on time. On the other hand, you will have your enterprise services like your integrated security systems, which bandwidth are intensive. So you need to ensure that the grid has enough bandwidth to basically manage all the applications that are flowing through. Then in terms of the artificial intelligence, there's a lot of intelligence now flowing within the grid. So we need to ensure that telecommunications is not the bottleneck going forward. Then looking at the value add, utilities these days, they also have an option to lease some of their cores to create more revenue. So back in the day, the telecoms used to be considered the support, but now it is basically becoming the key player on the new power grids or the grids of the future. Then let's look at our current state. We have written, I wrote an article in July titled Migration from Synchronized Digital Hierarchy to Meet the Technological Advancements in Power Grids. So as most of you would know that SDH has always reaching end of life. So there's a need to look at the technologies to support the critical networks. So as part of this paper, I did mention here that telecoms shouldn't become the bottleneck, and also we need to look at how we can improve and increase the telecoms transfer that it meets all the requirements of the services that are coming up and in the present one. So after we wrote this article, we also had partnered with South African Institute of Electrical Engineers. Then we did a webinar together on the 21st of August. We had 155 people connected. So it was titled Telecommunication Technology for Critical Networks. So we had presenters from Cisco in America, Huawei in China, OTN Belden in Europe, and we had people from all over the world basically connected to basically get the feel and the view of where we are in terms of this topic, because it's not only Africa or South Africa that is suffering from this change. So there is a need to migrate from SDH as transport and looking at the transport to basically support the core telecommunications network. In 2018, actually, that was just before I left eThekwini. It's one of the contributions we did for Paris. So this looked at how then, I think it's still now, the network, the communication networks looks for eThekwini. It's here one, which is your core network is purely made of synchronized digital hierarchy and DWDH. So both are reaching end of life. I'm still gonna explain how these technologies work. So mainly they support your backbone and your core, your high voltage SCADA systems, your protection basically based here. Then you've got tier 2, which is called backhaul network here for MV. So it also supports your SCADA, your remote engineering, and I think one of the projects Ethekwini was working on was the advanced distribution management system. Then tier 3 and tier 4 is more on your LV side. So I'm also convening and chairing a low voltage power line carrier communication working group. So if anyone is interested in joining that, feel free. And on the MV side, there's also the wireless GPRS, which is mainly your artificial private network. And there was a wireless mesh in Pinetown, which I think Subhash worked on many years ago. So I think this is still the state of how eThekwini electricity looks, and then I'm assuming they're also looking at how to migrate from the current to meet the new requirements of the grid. So how should we look at the end-to-end telecommunications then going forward? So for high voltage, one of the recommendations is to look at the use of multi-packet label switching and OTN to develop your core network. Then for your medium voltage, we look at your fiber and wireless. Then for your low voltage, one of the solutions which I basically decided to focus on since I'm convening this new working group is on the power line carrier communication. So most utilities all over the world, they had invested a bit on the high voltage and the medium voltage side. However, on the low voltage side, there hasn't been much investment because previously we used to only have meters here, but with the changes on the consumer trends and the introduction of electric vehicles in some first world countries, customers are able to basically sell electricity to one another. So there is a need to make sure that on the low voltage side, do not actually operate blindly. So there's a need to look at how to invest and which technologies to consider for connectivity there. Then the last one is space air-ground integration. My colleague Costa is going to cover that in detail, so I'm not going to touch that. And also, some other things which we need to consider here is some of the bandwidth intensive uh, services like your CCTV. So SDH is unable to cater for such. You will see when I'm presenting my next slide. So as part of the article that we wrote in July, please, when you get a chance, just go through it. We are looking at possible technologies to replace the current one, and it must be said that it's still a good technology. However, it is struggling now to meet the current and the future needs of the grid. So if you look here, SDH and optical transport networks, they have a lot of similarities. So I prefer to speak about OTN and compare it to a Gautrain. So for instance, if you take a Gautrain from Centurion to Sentin, you know that it's going to take you 20 minutes to get there. And then also depending on the lines that utility has, it can go up to 400 kilometer lines. So basically, if you've got long lines, this is one of the solutions to consider. It's almost a like to the OTN. Then I'm gonna look at also the internet protocol multi-packet label switching, which is mainly based on dynamic routing. So it's also able to meet and cater for telecoms operations, depending on the needs of the customer, obviously. So this one, I can just compare it by if you are driving from Umhlanga to Durban, I'm going to tell you whether to take N2 or M4 and which one is quicker there. Then there is a multi-packet label switching transport protocol, MPLS-TP, which is also a good technology to consider. With this one, you can predetermine how long it's going to take for your service to get there, and also you can create a second part just in case. Maybe if you're trying to drive via N2 and find if there's traffic, then consider sending packets via M4. So these are some of the solutions that are there, especially for the backbone to consider for the utilities going forward. Then on the medium voltage side, in the early 2000s, everything was just manual. To isolate you to send an officer to do that. Then in the early around 2010, we looked at the distribution automation systems, having some SCADA systems there. Then also, well, this is the journey up until you get to the intelligence side. So I included this slide to just look at where we currently are and how to get to where we desire to be. And I'm not sure how far Etegwin is with the ADMS project. So around 2020, most utilities they moved more towards looking at our OMS systems, like your outage management systems, your advanced distribution management systems. You have a bit of self-healing built onto it. But going forward, we are looking at a fully automated network. This is definitely going to take us a bit of time to get there. On the low voltage applications, as I alluded earlier, for the longest of time, we only had meters, and back then, meters were mainly used for billing, and that has changed over the last 10, 20 years. The introduction of smart meters, which uh, uh, basically can also be used instead of load shedding. You can just curtail, just drop the load a bit. Some of the services that is used for, and then also the bidirectional flow of data through these meters. You will see as I cover my next slide. So now, on the low voltage side, there is a need to ensure that telecoms doesn't become the bottleneck. We need to be able to feed the entire grid from generation to distribution down to commercial and low voltage side. So now, as I mentioned, that with the consumers becoming prosumers, and now they have in some countries, even here in South Africa, some electric vehicles. You've got your solar and your bus, and all of these are basically connected uh, onto the grid. And if this is not monitored and you do not see what is happening there, then it becomes a challenge. And it is important then to make an investment on the low voltage side. There are a couple of options to consider for that. And all as I mentioned earlier, I'm still looking for more case studies on the low voltage power line carrier communication. So it would be good to see some of the case studies that are being explored by the KZN chapter pertaining to this, and then feel free to share some of those. That is where I'm gonna end for now and allow my colleague Acosta to jump in. Christine is gonna introduce him. Thank you.
Thank you to Takani. Just a reminder to our attendees, you're welcome to and encouraged to post your questions in the chat box. We will be taking question and answers at the end of the presentations. Thanks once again to Takani, and I'd like to now welcome Mr. Costa Kalna. Costa has more than 35 years experience in the telecommunications industry and has been involved in numerous network deployments across Europe, Asia, America, with various global telecom operators and equipment suppliers. Among some of them are ICE Group, Telia, and Ericsson. The last 20 years, Costa has focused on deploying and operating dedicated networks in the lower spectrum. He's currently the chairman of a non-profit organization, 450 Megahertz Alliance, and the advisor for industries regarding deployments of private mobile networks. Welcome, Costa, and we look forward to your presentation.
Thank you very much for having me. Yes, so I thought I will try to connect a little bit here to what Takani started with and focus a little bit more on the wireless part and also why we see trends today moving into more dedicated and private networks being deployed around the world. I think if we're looking at the fundamentals with this, I think the reason, the beginning for it is really to have your own control. And that has been quite popular in industry, driven quite often by utilities, mining companies, and also railways in the past. Railways even have their own standard for private networks to roll out complete mobile networks, and I've had that for already from the 2G era. And they have found it quite good because you follow a standardization. It works with all equipments. You can mix different devices. You can buy what fits for purpose all the time as long as it fulfills the standards. And we're really focusing today when we're building on international ITU standards for EDPP. We typically build 4G and 5G networks, and we do it focused on purpose. So when you build your dedicated networks, you need to focus on what you want to cover. And a lot of it, as I say, is in the low voltage and also on the meter side, where we can see benefits for these networks. But it's also important to select the right spectrum and also for the right use, because it can be very, very costly. I worked with a utility in the US that decided to look at the high frequency spectrum. And I mean, if you compare it to the low spectrums that we see mainly being deployed today around the world in the 400 megahertz bands for distribution networks, it's almost 20 times the amount of infrastructure needed to be invested in. And when we're looking at the break even on these ones, it's quite hard to motivate those investments in this. So when it comes to working with utilities, and also in SAIEE and with other organizations on utility side, we have been focusing quite a lot on building the fundamentals first in the 400 megahertz band, and then you can pick other spectrums for private networks for your power plants and for other things. And I think just to touch on that as well, this is a slide that we did, I think, almost 20 years ago when we started to look at this, trying to figure out why do you need private networks, what are the reasons, and how does it fit with mobile operators versus satellite operations. And there is a mix. The consumer networks have large bandwidths, they can do a lot, but they are not very secure, and they're fairly open, and it's a lot of users there. When you build a dedicated network, you can focus it on what you want to build. It's purpose built. You can basically use it for what you want, and you can dimension it for the capacity you require. The NTN is a very scarce resource, and it should be used very carefully. It's very, very good to have. It is a perfect backup, especially in the critical comms sector, but it needs to be used for that as well, because if everybody would use satellite, we usually compare that the whole satellite system that we have is basically or that are available, and the spectrum available for satellite is less than the capacity of a major city, typically, New York, London, Berlin. The capacity in these cities are for mobile networks are greater than the whole capacity for satellite, and we need to consider that when we're looking at how we use that resource. Fundamentals to build is, of course, that there are suppliers, and there are quite a lot of suppliers these days that are focusing and contributing into the ecosystem for private networks. These are some of them. These are the ones focusing, many of them, on the lower spectrums, on utility implementations around the world. And we cooperate with them, I would say, from Australia, Asia, Europe, Latin America, North America, and also in Africa. So they are present more or less everywhere. And coming to that, where do we see deployments today? They are all over the world. When we're looking at global deployments with focus on lower spectrum bands or larger implementation, typically equal to utilities, the trends today is really quite clear. Utilities are probably the ones that implement most dedicated networks around the world to mainly, I would say, for power backup. You control your power backup, you control your network yourself. It becomes an intranet rather than an internet solution. You control all the traffic, you keep the traffic local, you have it behind your own firewalls, which makes it very, very simple to operate, and you can control it. As you can see on the map here, a lot of utilities have already started deploying this in different corporations around Europe, but we also see it coming up in Latin America and Asia. And we expect we are working with a lot of, we have a lot of discussions, I would say, in Africa at the moment. And that's also why we are present here, because we think this should fit a lot of your countries, or a lot of the countries in Africa as well, as even if it's mainly deployed for today, more public safety oriented implementations in Africa. We also see cooperation between these. As you can see, some of the operations here both supply, mainly they have maybe a utility driving the implementation or being the main customer, and they support backup for you utilities, for public safety, or for railways or transport or agriculture in the countries. It is a technology that are coming. We have seen an increase of about 50 to 100% annually in new networks and deployments. So it is something we see grow quite rapidly at the moment. And if we focus on the utility space, we can basically see that the area, if you look at the map to the right here, this is the networks or the countries where we have people looking or already deployed. Not always in the lower bands, sometimes it's in higher bands, but at least they have started to work with utilizing private networks. And we see even a bigger trend now with more and more networks being launched. And most of the network starts, as we say, in the low voltage meter, sometimes in combination. We have seen, for instance, in Asia, you have a combination where you use 400 megahertz networks or mobile networks to the meter and to the home, but in the home you might use a complementary Wi-SUN to build a smart home for the utilities. You might also have it for backhaul, as was presented earlier here with Tutikani, with PLC, that you actually do a local PLC, but you backhaul it via a mobile network. The trend is also that more and more are building a private network for the primary and a backup with the mobile networks. It's quite easy to combine multiple networks when you're following a standard where multiple spectrums can be used. If we look more at the production side, and I would say that also the reason why it becomes more and more important to have a more robust network on the edge is, as we said, we see a lot of prosumers, and therefore the security becomes much more relevant here. If we look at the production side, usually it's more fiber focused, high spectrum, not so, but still a mix but I would say mix of fiber and high spectrum, but still dedicated network. You can use commercial networks for backup and so on, and that's good to increase the availability, but it's usually not the primary, again, for security reasons. We are working like GSMR for railways. We're working at something called URS in ITU, which will be kind of a utility radio standard that we hope to get a more global presence of within the next year or two. A lot of work has gone in there, especially from Europe, US, and Latin America over the last 4 years. So it has come quite far. I can recommend to read in on that one as well if you have not seen it. And last, maybe just an outlook. Why do we think this is a good idea? And I think tying back to a little bit the prosumers, we get more and more local power production. To maintain networks to be stable, you need to also have a stable communication to be able to see and visualize and know what production is coming, what are produced going into the distribution network and what is going out, so you find a good balance. And that ties in quite a lot with the digitalization here. To be able to monitor and build digital twins to achieve a more predictable network balance with power systems, you need to build more and more infrastructure also on the telecom side. And with the digitalization and digital twins builds in also the AI capabilities and automation to avoid blackouts and maintain stability in the networks. It becomes more and more complex, and it requires more and more automation. The fundamentals is you don't want this on an open network. You want it to be fairly closed and secure, and therefore we see that most most utilities going this way are connecting it to a private network that they control themselves with their own spectrum, with their own infrastructure. And we say that here, and we quite blunt, it is usually anchored on a low spectrum where you can get affordable and stable connectivity over a large area, because I think the area coverage here is essential. So with that, I leave it back. I can recommend to listening to a couple of our webinars. We have an event in Krakow in a week, and I will also be in South Africa in beginning of October. So feel free to also reach out and connect if you want to discuss more around this. With that, I hand back to Tikani, I think.
Yes, thank you, Gusta. And we'll hand over to Tikani.
Thank you so much, Crystal, and thank you so much, Crystal. Oh, wait, so much to nominate. Okay, can you hear me now? Thank you so much, Crystal, and thank you so much, Crystal. Yeah, so the second part will focus more on strengthening cybersecurity with special focus on critical networks. On this section, I'm also gonna lay foundation from the high level. Then our other colleague from Amin is going to provide more of a detailed case study based on the OT cybersecurity as well. So, okay. Technology is not technology now. Yes, so now I'm able to move. Yeah, so one of my preferred architectures or designs that come about these days is based on the software-defined networking. As part of the session that was held, the webinar on the 21st of August, Cisco nicely covered this topic. So I think later on that webinar is also going to be available on SIGRE and SAIEE, basically platforms for those who couldn't attend in person. So software-defined networking covers both the networking and the cybersecurity, where there are two patterns to it. One is based on software wide area network, which is basically the networking component where you've got your centralized control plane, which basically controls your switches, which tend to be your data or forwarding planes on site. Then you also have a secure access service edge, which is your cybersecurity component, which is more decentralized. So let me use the case study based on the renewable power plant. Spent more of my time these days on the renewable power plant. So here, the case study which I'm using is based on the renewable power plant using two different forms of transport. One is multi-packet label switching. The other one is based on internet. The beauty of this networking platform, it supports all transport, which includes your 5G and 4G as well. So here, one of the reasons we move more towards SD-WAN is to basically reduce white boxes. What do I mean by reducing white boxes? Now you need less equipment to build a network. And also, for instance, let's just say this is one of the substations, maybe in a substation, for instance, then you need to go change a switch there. You just basically forward the configs there and just do a plug and play. And it's also perfect for the concept of working from home with these centralized VPNs. You can have two different VPNs, one basically focusing on your enterprise and one focusing on your critical networks. You can have your IT domain and OT domain. So which allows a secure connection to the plants as well. I'm still gonna touch that in detail as I proceed with my slides. So one of the ways we use to protect the network is based on firewall protection using next generation firewalls, encryption techniques, basically through the AAA authentication, your intrusion detection systems, and your secure access controls using the correct VPNs, and also the terminal access control access systems, which basically allows you to know who connected on 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 which server and accessed which platform. I think Amin is gonna touch on that way in detail later on. So myself and Homo Beto from ASCOM or NCCSA these days, we wrote a paper which we presented in Norway. It's called Demystifying IT-OT Convergence, Strengthening Critical Infrastructure Security through Demilitarized Zoning Implementation and Cross-Domain. So I'm not going to focus much on the firewalling. That Amin is going to touch more on that. I'm going to use this paper to focus on the people, processes, and technology. So basically, those are three important aspects when you are looking at the cybersecurity and protecting the network. So basically, one of the challenges which are faced by many utilities in the world is that for so many years, the OT team, including your SCADA engineers, used to manage the OT alone. But with digitization and the introduction of internet protocols, your IP is now unique to ensure that your IT and your OT departments work together. And that also is not the only challenge. On the IT side, your asset has a lifespan of 3 to 5 years, whereas on the OT side, it is 20 years. Then you find that these two departments they fall within separate managers, meaning that you also need to deal with the silo mentality. If this guy is trying to get to the plant, at times they need to go through this guy. Then looking at the substation itself, the physical system will be your transformers are sitting up there, your primary plant. Your sensors and most of your actuators will sit on your secondary plant. And then also what I want to basically cover here, that it is important to break the silos to actually ensure that the IT OT collaboration is basically met, and to ensure that the digitization is basically achieved. Because with digitization, but now we need additional skills which previously we didn't need as much. So now there's a need for your data scientists, your IT guys to basically be able to understand how the network is basically performing. You look at your data availability, your data quality, amongst many other things, which back in the day it wasn't the case. So one of my colleagues say that digitization is the answer to the myth. Now it's basically a necessity. It's no longer a support system in this case. So next month is a cybersecurity awareness month. So I just put on the slide to remind us of that. So a couple of utilities and enterprises around the world, they've been hacked. So it is important to focus on the training aspect as well. I'm not going to focus much on that. Today, I want to focus more on the operational technology side as well. So Patrol model is one of the most common standards that I use basically for critical networks. I'm going to create a bit of a case study to just quickly go through this. Let's just consider this as an all-fault substation. Your level 0 to level 2 is the substation itself. You will have your transformers there. Then through, okay, so how it actually works that from level 0 to level 3, it's mainly operational technology side. Then level 4 to 5, it's mainly your IT side, and they are all segmented. So level 0 is mainly the primary plant, in this case, your transformers and so forth. Then on your level 1, you will have your SCADA gateway, which is your remote terminal unit. Then your level 2, you will have your engineering workstations. You will have your historians and so forth. Then through the SDH network that the comms department provides, then it's able to get to the control center in all faults to be able to do the wide area monitoring and control. Then in terms of the data manipulation and whatnot, I'm not sure how far the KZN chapter is on that, but some of the utilities are around the world, they monitor data availability, data quality, they make use of SES and so forth. So what I'm trying to cover here is that the IT-OT collaboration is more important than looking at the IT-OT convergence or divergence. So we need both sides to work, and some of the benefits includes a holistic security posture. We can share this slide to basically go through them in detail if one needs to. And in terms of looking at the cybersecurity by design, this is what most utilities are looking to work towards. So it is important to look at where most of the utilities within the KZN chapter are, and they need to consider cybersecurity by design from inception and from each of these levels. So I think I'm going to hand over to Crystal to introduce Amin. Thank you.
Thank you, Mr. Biela. I'd now like to introduce you to Mr. Amin Hamdan. Amin has over 35 years of operational technology experience. Amin began his career as a SCADA telecontrol engineer after obtaining a BSc in electrical engineering in 1988. Since 2000, Amin has been the president and CEO of Subnet Solutions, Inc. Subnet specializes in software solutions that electrical utilities and other critical infrastructure asset owners use to integrate, manage, and cybersecure intelligent OT devices deployed to monitor and control their critical infrastructure. Today, Subnet has clients in over 65 countries and secures critical infrastructure of major asset owners in 6 continents around the world. Thank you, Amin, and welcome, and we look forward to your presentation.
Hi, thank you very much. It's a pleasure to be able to participate in the webinar here today. I think this presentation will build on the prior presentations on the security and a lot on what Tutukani just spoke about on the network side. on this part, we're focused on the cybersecurity applications, really at the application layer. So once we have the secure network and we're securing over the software-defined networking and communications infrastructure, how we secure at the application layer the devices to meet the needs of our modernized grids. So this slide, I think, for everyone, the transition that we're seeing today from a traditional power grid to the modernized grid is quite dramatic, and the level of complexity to manage our dynamic grids with all of our renewable generation and whatnot, where now we see at many utilities over 50% of the generation coming in at the distribution levels and being quite dynamic throughout the day, depending on events and weather and whatnot. So our ability to manage those more complicated grids has increased exponentially, and utilities are having to invest quite a bit more into the automation and the communications infrastructure to manage these more dynamic grids in real time. And so we see utilities at the distribution level investing not just on distribution SCADA, but the advanced distribution management systems, and with capabilities of the advanced apps for feeder automation as well as volt bar control, which is very critical these days with the introduction of so much renewables onto the network. Managing voltage and whatnot is a key concern. There's even greater need and expansion for substation automation and SAS 61850 substations, and automation at the station level and control center modernization, as well as much more asset monitoring and asset management on those distribution assets, the distribution transformers and the faults, and just gaining much greater visibility of the distribution network, a far cry from where we were only a couple decades ago, where utilities had almost no visibility of their distribution networks and had systems that relied on call centers to learn what the status of some of their distribution networks were. And obviously with DER and all of the introductions there. So with all of this new capabilities, it's not just those new automation systems, but a dramatic increase in the amount of digital devices and connected devices that we're introducing to the power grid that is supplying data. So we have utilities all deploying thousands or tens of thousands, and some utilities that will break 100,000 devices that they will introduce in the next decade for monitoring their distribution networks within the distribution substations and throughout the distribution networks. And in this industry, there's lots of vendors with innovative products. And so the mix of devices that utilities have choice to deploy from and are bringing innovative solutions to is quite vast. So there's a large mix of devices that get deployed for managing all of these devices, and in the ADMS that can have that real-time communications. And now we have utilities that have an ADMS that's connected to tens of thousands of devices from all these different vendors. But the flip side of that is, with all of these new connected devices, the OT cybersecurity challenge and the management challenge of all of these OT connected devices is quite extensive. That all these devices all need to be, their configurations need to be managed. They're going to be interrogated at points data collection, point maps. They're going to need to be updated on configurations over time. There'll be patching that will be required to address any vulnerabilities and CVEs that are introduced and identified in the products, and testing, and of course, how are they cyber secured? And so the OT device management risk is increasing exponentially now with all of these introduction of connected wireless devices that have control capabilities on our distribution network. And on top of that, there's a huge risk for O&M expenses for managing all of these devices. And as you migrate from SaaS systems and have all of these distributed devices through on the feeder network, you have it's not 10,000 devices in a few hundred substations, but tens of thousands of devices in tens of thousands of locations. And so that management is there. And so utilities are investing for the operational benefits, but they don't want to lose that value with the O&M expenses that they could be faced by that. So the dual challenge is how to minimize that cybersecurity risk and attack surface while also managing the labor effort and labor intensity and human performance risks of managing all those devices. And when we look at our standards today, on the SCADA communication standards over the last few decades, there's been very good standardization of SCADA protocols with 101 and 104, DNP3, 61850 and 103 protocols. I've really supplanted what the industry looked like a few decades ago with many vendor-specific SCADA protocols around. But when we look at the other communications interface that all of our OT devices have, is the management interface. The standards are not consistent from vendor to vendor, and there's many vendor-specific differences on how we will log into the device and what cybersecurity capabilities and passwords are supported in the device, how those devices are configured. Will have their own vendor-specific configuration tools. And so the process for how you change settings can be very different, and the process of how you would update the firmware, again, can be very unique to the vendor. So you have a large mix of differences there that need to be managed when you have a large mix. We talked about secure remote access and the Purdue model. This is a more simplified one with the level 5 at the corporate LAN and the firewall security, which is more the 3.5 level, and then down to either the station level or the device level here, just showing more of the feeder devices that may be connected over a wireless network. And so secure remote access is usually the first step utilities will look to, is to centrally control which users can have access and that connectivity access to those field devices, and not just the network connectivity, but then also at the application layer. So this would complement at the application layer really what the WAN, LAN, firewall, network security, and other ICS tools. You're tying in that access to your single sign-on, multi-factor authentication of your corporate logins. And ideally, you can have some more granular function-based control over the devices and what users, which devices they have access to and the levels that they could connect to. And with the goal that access is only provisioned by policy and that the end users don't need to be aware of what those end device IP addresses are or the device passwords are. So that's kind of at the highest level what we're trying to achieve with this more application layer security is over that network when we're trying to control which users can interface with those devices using those different tools. How can we achieve that? And then also control and ensure that the vendor software that they're using to interface with our operational devices is valid and secure as well, because we're well aware that that's another vector. That's where if you've got malware introduced into your vendor software can cause some issues. So a way to that you have that security and secure that only the proper software is being utilized. So the secure remote access, if we have that connectivity so that we're not just talking over the SCADA communications to all those devices, but from a central location, users can access into those configuration maintenance ports as well. Then we can control from a central location which users have access to those field devices on the configuration side in parallel with the ADMS that's doing the real-time SCADA data collection and data communications. And that's very useful and then at least if you've got thousands of devices over a large geographical service territory and allowing that centralized access. But the saving of that drive or having to travel to those devices is although it's a significant benefit, because of all the differences, utilities personnel will still be manually updating the device passwords if they want to ensure they're meeting a level of complexity and uniqueness. And if people were to leave the organization, you can assure that they didn't leave with the knowledge of device passwords that you wouldn't want them to have retain post their departing working for the organization. When you're reading or updating device configurations and confirming the settings are as you believe they are, or if they've been updated, confirming what the new settings are, manually logging into the devices to do that. If understanding and reading and updating the firmware version. So if you're getting your CVE alerts that there's an issue with a certain device of a certain version of firmware or older, the big challenge for many utilities is understanding what the impact of that is. How many devices of that do I have in my install base and that are impacted by this vulnerability? And what would my remediation plan be to have a plan to update those and address those in an organized way? There's all types of additional non-SCADA type data from these devices that's high value in relays and reclosers, your event files, and SOE data. And then ideally, and is required in many jurisdictions with cybersecurity regulations, that you manage and monitor the baseline of those devices so that you have a record of that the device is operating with the correct configurations and validated firmware settings, and then have the ability to monitor those over time and to be able to detect any deviations from those baselines so that you have a full. And to do all of this manually is a pretty significant effort for labor intensity, and where utilities have regulations that to ensure that this is done for compliance, there's a large human performance risk that to ensure that these processes are being done correctly and in a timely manner as needed to meet their requirements. And so there's still a very significant labor intensity human performance risk to it. So the ideal scenario is being able to automate those password changes so that devices that may have 7 different passwords in them can be changed on a regular basis to new complex passwords without a large effort, manual effort. The reading and managing of your configurations, settings, the reading of the device firmware, the data collection of some of that event file data or other non-SCADA data, and then taking all of that data and using it to manage and monitor a baseline and be able to get alerts as those baselines change is key to managing the cybersecurity of your devices and ensuring they're working as intended and configured as you believe they were and were tested too. And then having an auditable record of that from that you could produce as required from a regulatory compliance point of view that many jurisdictions would have. And that would have both a huge cybersecurity advantages in managing unique passwords, but also huge operational benefits by reducing that labor intensity required to have to manually manage those devices. And many vendors will offer their own solutions to manage their fleet of devices. And so you can have a solution that will manage all of those devices from that vendor. And that solves the device management problem, but introduces a secondary problem that now you have multiple device management systems that you need to manage for all the different types of devices that you have, and setting up the users and the databases and all of the infrastructure to support these multiple systems becomes another management issue. So you're trading one issue for another. And so the ideal is to have a solution that can provide you a unified interface that can secure it and align and unify the cybersecurity and the OT management that's unified across all the field devices that you have deployed within your infrastructure. And then you can set up policies for how you manage your devices across all your different device types, regardless of vendor or model. And so having a unified way to manage that, and just a few screenshots for regardless of vendor and all across your different substation vendors, your different gateways or networking switches, your Flizzr devices and reclosers and ring main units, or even your voltage devices, your tap changer controls, voltage regulators, cap bank controls. You have a unified way to manage all the devices from all the solutions. And then what that does is give you that record of all of the devices you have deployed and a real-time management and automated management of those devices. So you can enhance that secure remote access to that secure access to automated device management solution. And then again, have that paired with your ADMS. And there's another key advantage with that is when you can tie those two solutions together, there's a huge value that the ADMS, when it's making those grid automation advanced app decisions that are so critical to managing our dynamic grids, they require accurate data inputs. And, so if it's making decisions based on bad data inputs, you're going to get bad automation decisions as a result. And so ensuring the correct data that's in there. And one of the key pieces of data on an ADMS, because they're really non-trivial systems, and there's a lot of on the GIS side of the mapping and understanding the physical properties of your grid and all of the equipment, but also understanding the settings of your field devices and ensuring that they are as accurate when this automation logic happens. And so a big challenge for many utilities in managing these systems is ensuring that the device configuration settings match that are actually in the device are known by the ADMS system. And it's not what we tested a month ago or what we believe is in that the settings are, but the settings that you know to be current and accurate in the devices and what they are right now. So when we're making those decisions. And many of these devices, like reclosers, will have active setting groups. So in a storm mode, you have a different level of protection settings than you would in on a hot day. And other in a fire mode, you may have another set of settings. So understanding all of those setting groups, which is the active group, but then which other groups are configured in the device that you could switch to, is a key challenge for the utilities and in managing these. So knowing what for your fault isolation, really understanding what the actual configurations are in your feeder breaker devices and your reclosers and ring main units is critical. And having an accurate knowledge and current knowledge of the settings of the voltage regulators, cap bank controls, and other tap changers that affect voltage is key to ensuring correct operation on the volt var side. So a real world example with a utility in North America that had 14,000 reclosers within one state, connected reclosers, and they wanted to understand what all the different setting groups were for all 14,000 devices. And option was to have someone use the remote access, log into each of these devices, collect those setting values from those devices, and populate a row for that specific device. And except that would take 5 days a week, 8 hours a day, 14 weeks, about 1,000 devices a week to populate that. And with an automated device management system, that equivalent task could be done in a few hours and produce the same resultant. And so massive savings on the side and ensuring accuracy on the human compliance side of it, because all of it was automated, and versus human error that just naturally is going to happen for someone that's working on this for 14 weeks straight. But the real value is then being able to connect that data in real time to the ADMS. So the ADMS is fully aware what those settings are in active and in real time. So having that ability to connect the settings data and of the current devices along and complementing the real-time SCADA data communications that you have with those devices all become and make part of ensuring that when these automation algorithms are running and operating, that they're utilizing the correct data and making the best decisions possible based on the data that's available. So that was really the key there, is that the cybersecurity, by managing the cybersecurity and ensuring that we can have granular control and automate which users have access to the field devices and automate that management, you can have a record where we know once the device is put into service, the full history of that device, who all the personnel that access that device, the full history of the configuration changes, password changes, firmware changes, is all tracked in your asset inventory for the life of that asset. And then being able to integrate the current state of each of those devices with the ADMS so that it's fully aware of the true settings of the device at any moment in time is key to helping ensure that the management of these advanced apps are there. So it's very interesting when we started this cybersecurity solutions 15, 20 years ago, when cybersecurity regulations were first being introduced for utilities. Many of the utilities felt they were doing it only because they're being required to. And now they do it because the operational benefits stand in and of itself, and without any regulations, they're implementing these solutions because the value of managing the devices and having this knowledge is that much more critical. And regulations are not, they're implementing these solutions. So it's been a very interesting see how utilities are taking cybersecurity very important, and the managing of those devices and ensuring that they're managed and maintained in the most effective way possible. And so this is the topic that we've talked about today, and I'll hand it back to Tukani.
No, thank you so much, Amin. I think now I'm left with almost life, then I'm gonna conclude. Yeah, I think cybersecurity is now a necessity. So considering cybersecurity from the inception of the project and also ensuring that you protect the asset. And I'm moving to my last slide, or second last slide. Focuses on the AI and IoT in electric power utilities. So we say that these days, data is the new gold, and with all the sensors that Amin spoke about, so basically that interpret into something. So back in the day, very few utilities around the world focused on asset management. Now asset and operational management, they play a significant role for a lot of things, including predictive maintenance, grid monitoring and optimization, your demand forecasting and load management, and also in renewable sector we use them a lot. I did speak about the fault detection and automated responses. Then looking at the energy theft and fraud detection, I think one of the pilots that Sitsoftware is running using as smart meters focuses on this. So yeah, so now we are in an era of digitization and we need to make most of it. So in closing, so looking at another AI application, more than 2 decades ago, we used to have people are climbing on transmission lines. Then we've moved. We then moved to the use of craft, including helicopters. And now we are in the era of drones. And now you can just basically run a drone and basically have an idea of how each tower looks, if any of the gang members is loose and whatnot. Then basically, it is even cheaper to manage drones versus the use of aircraft and helicopters. So we need to make the use of the technology that is out there. Then AI and robotics as well. One of the applications which is quite common for management is the use of intelligent establishing systems, where you can have a camera which can basically read the temperature of the particular transformer, and then you use all that data for predictive maintenance, amongst others. The use of robot dogs in robotics is basically growing for both safety and asset management. So with that said, looking at where we are and where we were, everything was isolated and managing silos. The digitalization era also focuses on not only the high voltage side, it also looks at the cybersecurity and networking and ensuring that these are key going forward. That will lead to the slide which I basically presented previously, which looks at the future and the next generation power systems. So we are running out of time, so that's why I'm running through these slides. With that said, I'd like to hand over to you, Crystal. Thank you so much.
Thank you to Takani. And thank you to Amin and Asta for your presentations. I'd like to remind the attendees to post your questions into the chat box for those of you that have a few questions. I'd also like to remind you, we have shared a few links in the chat box, how to become a member. Our brochure for our training academy has been uploaded. There's a PDF where you can browse through our training academy courses that are available. You're also welcome to register on the SAIEE TV channel and to follow us on social media. Okay, I'm just going to scroll through our chat box here. So Fumotso has mentioned on the substation automation system side of things. Is there a legitimate reasons as to why utilities are not adopting SDN? There has been a response from one of our attendees, but I'm not sure if any of you, Tutukani, want to tackle this.
Okay, let me first see the response from the attendees. Okay, unfortunately, I cannot. Can you read the response first from the attendees?
Great.
Then I can
Okay, so Gabriel says, great observation in my opinion. Prohibitive cost of SDN switches, especially for smaller utilities, but as they progress in market ubiquity, the prices should fall and the barrier of access. So when we reach regional IEC 62443 reaches regional enforcement, it will be the only way.
Yeah, I think I agree with the person who answered that. So the software-defined networking is basically becoming a way to go, especially to I think Cell has done a lot of work in that space where they've created SDN-based for critical networks. So previously, software-defined network was mainly looked or considered for enterprise, but now with the maturity of the technology and the ongoing research, I think basically a lot is basically being done there. And in terms of price, I don't really think SDN enabled switches are more expensive than the traditional one. So it goes down to the preference. Then looking at how you configure those as well. One of the benefits of going with AI SDN enabled solution is that you plan your solution once, and if one of your switches fails, then you are able to just remove it and put on a new one. Then if you need to actually block one of the ports, you do not actually need to send a technician or an engineer. Then you can do everything centrally. So there are a lot of benefits associated with it more than anything else. Thank you.
Okay, there's another from Komotso, and I'm just going to take two more questions. Just having a look at time, we're running out of time. So going into the future, physical and cybersecurity must work together. His question relates to a significant challenge that we face, the theft of steel. Sorry, I think as the questions are coming in, I've just lost the question. Yeah. So the theft of steel components from high voltage pylons, which compromises their stability and leads to collapses. So as seen in the recent case in Pretoria, where 7 structures collapsed due to vandalism, this is a major safety and reliability issue. Is the subnet platform equipped to integrate with IoT devices, such as vibration sensors on transmission pylons?
That specific use case would be one that would be new to us, but that's not uncommon where we get requests to interface with different devices. But that one is not one we've done to date, but would be I suspect would be one that we could manage fairly quickly, just in understanding and learning more about the specifics of the device itself and the interface that would be required.
Just to add on that, I was basically rushing through my last slide. So with integrated security systems and more focus from the utilities on the asset management and operational management, a lot of utilities, especially locally, they're looking at that. Then there are a couple of ways which that is done, either through putting sensors on the towers. The second one is through the fiber that is run in there. So basically, there are a couple of AI-enabled solutions as part of the integrated security systems and asset management, which a lot of utilities are now focusing on, because now it is important to focus on one, ensuring that you know all your assets, looking at the safety and also knowing when to maintain it. And the utilization of drones as well helps in terms of how these packages are designed. So you can have an IoT device on a tower, then if there's any significant movement, then a drone can automatically fly to that basically tower and basically do some monitoring. Then if it sees something wrong, then it basically sends a signal, then the guards or whoever come and assist with that. But those forms part of asset management and integrated security systems beyond anything else. It's not on the OT side, but it's more on the integrated security systems, which is more on your enterprise and your assets and operational management. Thank you.
Thank you for that. I'm going to take the last question, also from Khumoto. Does subnet solutions work in other critical infrastructure environments, such as water and wastewater, for example? He's curious if the Power System Center's capabilities in process control and instrumentation can be applied to those sectors as well.
Yeah, thank you for the question. Power System Center, we have customers and other critical infrastructure ones. Wastewater is not one, but we have some other gas and pipeline companies, and water, we have some water utilities that are now looking to deploy the solution as well. Usually they're sister companies to the utilities themselves. So it's definitely something that applies across the board. Many of the devices are the same. Some of the use cases are a little bit different, but yes, it's the power industry is by far and away where we're the strongest, but we do have solutions across other critical infrastructure asset owners as well. Thank you for the question.
Thank you. And thank you once again, attendees. We don't have any further questions. Thank you to Amin, to Tikani and Gusta. We appreciate your time and your insights. For those of you that would like a copy of the presentation, please email us on kznc@saiee.org.za. I have posted the email address in the chat box, and we will share the presentations with you. Thank you once again, everyone. I hope you have a good evening and take care. Goodbye.
Bye, everyone. Thank you.
Thank you, everyone.